Morekwa starting today,
Sorry,
and I think it's just about time.
Yes, in the interest of time, we probably need to go. I'll continue admitting people as they join.
Yes.
Yeah. Okay. So, good evening, everybody. I'm just hoping that all of us have our mics off. And hopefully you have had a restful weekend after such an engagement with us for the 2 sessions. So we will be continuing from where we left on from. The last 2 days, we covered what the course is about. We also covered just the general of what psychoactive substances are and their general effects. And so we're going to be continuing from that end. So I'm just going to share the slide. So we'll be moving on to module 3. Okay. Slide show. Here we go. We will be moving on to module 3, the science of addiction. But before we do delve into module 3, I wanted us just to take a moment to just reflect on the content that is covered thus far, and then ask any one of us to actually just share with us what they thought about the content, and if there's anything that they learned that applies to their job before we go into module 3 for today. Any volunteer to just share with us what their thoughts are in terms of the material that is covered already, and in particular, what is it that they learned that they might be applying to their jobs? Kerry, I don't know whether you can raise your hand, it still applies, so that Kerry can just pick a yes. Fatima, I see that Fatima has raised her hand, and so you can go ahead, Fatima.
All right. Good evening, everyone.
Good evening, Fatima.
Yes, in the last module, I learned a lot. In fact, I just knew that you can, another route of using drug is through the vagina. That was very strange to me. You know, it was really very strange. And because I have female clients, it's really going to make further, you know, in case you are not seeing what the client is doing as a woman, it's good to know that there are other routes like the vagina. Also, I have a question to ask. During the my reading, you know, you are talking about different stage of using drugs, like the occasional user, regular user, and all that. I want to know at in what of those stages will a use become a risk? When somebody is using in any of those stages, when will it be a risk? You know, when will it pose a risk to the user? Is it when the person is occasional user, when the person is a regular user? When exactly will it be a risk for the user?
Yeah.
Thank you.
No, thank you for the question. I think it's a pertinent question. As we go through the modules, because there's no one direct answer to that question, we will discover that a lot of factors to contributing to one being at risk. And I'm sure that towards the end of the curricula, you would have your answer to that. And so we will be starting to answer your question actually in this module as we go along. But thank you for sharing your experiences, and it does show that you are continually reading the manual. So
yes, thank you.
Now, for this particular module, we hope that by the end of the module, we will all be able to define addiction and have a consensus definition of addiction, because there are many definitions out there. We'll also importantly discuss why addiction is actually considered a brain disease, very important for us as addiction professionals. We'll also provide, we are hoping that you'll be in a position to provide a basic description of how psychoactive substances create the effects in the brain. So for just a minute or 2 minutes, I would want us to just share our thoughts on the chat regarding what addiction is and those that are addicted. I'm aware that we do have people that have already taken the UTC or are already in the field already. But what I'm hoping that we get to is even just what other people in our communities actually think about when people talk about addiction or when people describe people that are addicted to substances. So I'm just going to give you a minute just to share your thoughts, what your communities think about what addiction is and people that are addicted. And don't censor yourself, anything that comes to mind. So we start our minute now. What do you think is addiction? What do you think about those that are addicted? Nice, welcome. Any responses?
Yes, some people think that those who are addicted are weak in character. People that are addicted are useless to society.
Mm-hmm.
I think addiction is when a person continually uses drugs without knowing when to stop.
Mm-hmm.
People who are addicted are seen as irresponsible in my community.
Mm-hmm.
People who are addicted are considered to be bewitched.
Interesting. Yeah.
I think that's all of them.
That's all. Okay. No, thank you for sharing. And it is these misconceptions that we have to actually address, because we do have people coming into our practice, the students that we're going to be teaching. But one thing that we know about addiction is not a character flaw, as some of our community members think it is. It's not a personality disorder. I know some people said they've alluded to the fact that some of the communities believe that it's a moral failing. Addiction is not a moral failing. It is a health problem. The US NADA describes addiction or defines addiction as a chronic, I've underlined chronic, relapsing brain disease. There's a reason. It's chronic. It's a relapsing disease that is characterized by compulsive substance seeking and use despite harmful consequences. When you look at the definition of addiction that is here on the slide, it actually relates more to the DSM-5 diagnosis and the ICD-10 that we actually talked about in terms of what SUD is. So it is a chronic relapsing disease that is characterized by compulsive substance seeking, use, and despite the consequences that are usually harmful. Now, why is addiction considered a disease? First and foremost, we'll look at the definition of what a disease is for us to understand why addiction is considered to be a disease. A disease is alteration of the normal structure, right? Structure or function of any body part, organ, or a system. It is characterized by a syndrome or a set of symptoms and signs. When you think about addiction, addiction is a disease in that the organ that is actually altered is the brain, as we've already mentioned from Dr. Beatrice's presentation last week. And therefore, it does qualify to be considered a disease just in that manner. that there's an organ that is actually altered by the use of psychoactive substances, which is, right, for now we would say the brain. Now, looking at what characterizes a disease, we said it's disruption of functioning, disruption of structure, and it's characterized by symptoms and signs. Now, what are symptoms? Symptoms are subjective. These are things that are directly experienced by a person, but they're not overt to the person that is observing that individual. So when you have a client, you'll probably not see other symptoms, but they would let you know and share what they are experiencing. An example would be a stomach ache. You cannot observe a stomach ache, but it's something that is individually experienced. You cannot observe fatigue or dizziness. Similarly, in terms of the symptoms for those with SUD, they have cravings, anxiety when not using. And therefore, you can see that when you look at the definition of addiction, it does qualify as a disease in that, number one, we've already pointed out that there is an organ that is being disrupted or in terms of functioning and structure. There are symptoms. An example is here on the slide in terms of craving and anxiety, which are things that are not overt. And then we said a disease is characterized by signs. What are signs? These are objective. These are physical indication of a disease that can be observed by one person or another person. An example, when you think of disease, it could be fever, which is indicative that there's something wrong. High blood pressure, skin rash. For high blood pressure, you can measure it. For fever, you can measure it. For skin rash, you can actually observe it. So it's very overt. Now, coming to our definition of addiction, how does it qualify in terms of, can we see the signs? Of course we can. Abscess at the injection site for those people that use or take drugs by using injections. And so where they inject, you can see an abscess. And so the definition, going back to the definition of addiction, it qualifies because we see that there are signs in terms of addiction. The other way in terms of looking at things that are overt or that are easily observable is by using imaging techniques where you can actually measure or look at brain activity. Examples of those are the MRI, which is the magnetic resonance imaging, the PET scan, which is the positron emission tomography, and then the SPECT. These are techniques that can be used to show activity of the brain and how the brain is impacted by the use of psychoactive substances. So there's clearly evidence in terms of things that can be observed or things that are reported by individuals to qualify addiction as a disease. Looking at addiction furthermore, there has been research that has been done to actually look at the brain of healthy individuals or the brain of people that actually use drugs. In this picture, I'm hoping that it's clearer to those that are watching. On the left-hand side, it's a healthy brain, right? And then on the on the left-hand side, it's a healthy brain. On the right-hand side, it's a diseased brain of a cocaine abuser. You can see in terms of the metabolic rate, the healthy brain, it is very high, and then for the cocaine user, it's very low. So your y-axis actually shows the low and the high metabolism rate here. Similarly, there is a difference in terms of metabolism rate, looking at a healthy heart and a diseased heart, right? So why are we showing the slide is just to evidence that addiction actually qualifies as a disease. You can see the biological changes in terms of the structure or the organs in the body, which is one of the qualifiers of why one would say something is a disease. It disrupts the structure, it disrupts the functioning of a body organ or a system. Now, anytime when we talk about a disease, there is usually or common that there is an etiological agent or a causal agent, something that causes a disease. An example for AIDS, the etiological agent is HIV, human immunodeficiency virus. For a sore throat, it could be bacterium. Now, with regards to addiction, the agent that causes addiction is the psychoactive substance. Of course, there are other factors that play a role in terms of addiction or in terms of any disease development. Like right now, if there is a cold virus, not everybody who's exposed to that virus will probably get a virus. I think the question that Fatima earlier on you asked in terms of what is the risk, so it really depends. There are a lot of factors that come into play when you think about the disease development or the pathogenesis of a disease. So there are other factors that has to be considered for us to say that this one thing causes addiction. The substance in itself alone might not necessarily be enough for one to develop addiction or to become addicted. Other factors, when you look at the heart disease, for example, is the environmental lifestyle issues. They also play an important role in terms of development of heart diseases. The other issue is the genetic makeup of an individual. It also plays an important role in terms of development of any disease. Similarly, the same is true with addiction. I've already mentioned this issue of genetics. We could think about genetics when you look at a lot of studies that have looked at twin studies where the same twins are raised in the same environment, and the same twins, the twins are raised in different environments, to see how the importance of genetics and the interplay of genetics and the environment play in terms of presentation of any disease. So addiction, similarly to other diseases, they have something that causes it. There are other factors that we have to consider in terms of understanding the development of that disease. There's a term that we also have to consider in terms of the progression of a disease from its origins through its critical development and expected outcome, which is the pathogenesis of a disease. Most diseases, when untreated, follow a generally predictable path of symptom development and biological changes. So Fatima, you can see that there's sort of a progression that we usually could make predictions using, but as I've already mentioned, there are other factors. So when you look at addiction and compare it to other diseases, it follows the same progression. Last week, when Beatrice was talking about just the progression of experimental use to addiction, you can see that there is a pattern. Somebody doesn't wake up and get addicted, right? So there's definitely some sort of development that goes in terms of somebody ending up with a substance use disorder or getting addicted to a substance. And there are development and biological changes that go with that outcome. Going back to the definition, we had said that addiction is a chronic disease, right? We said it's not only chronic, but it's a brain disease. It's chronic in that it's long-lasting. Despite the fact that it's long-lasting, it can be managed, though it cannot be cured. So when you think about chronic diseases, most chronic diseases are long-lasting. They cannot be cured, but they can be managed. And they can be managed, more especially looking at addiction in terms of pharmacological interventions, as well as counseling interventions, or the combination of the two. So addiction is a chronic disease. It qualifies as a disease, as I've already highlighted. The chronic nature of it actually comes in because there are distinct changes that happen after prolonged use of the substance. The unfortunate part is that these changes actually persist long after the substance has been stopped, right? So that is where we see the chronic aspect of addiction. So just thinking about what we said earlier on about what our communities say, when they say no, they can stop it, or it's a moral thing. There is a clear understanding that this is not a choice where somebody just makes a choice that, okay, I'm now going to stop addiction. It is a biological disease. I want us to make sure that that is a point that we take, most importantly, to understand that addiction is not just something that somebody can get over overnight, right? And the fact that the changes in the brain persist even after use, it's also one that actually we should pay attention in terms of why we say it's chronic. In a similar fashion, just like hypertension, diabetes, we've already said that it cannot be cured, but there is possibility of recovery. I think we should always mention that recovery is possible because it can be managed. Okay. I've already mentioned that substances actually change the structure of the brain and how it works. And when Beatrice comes in, like after I present, you will be shown in terms of how actually different drugs actually affect the working of the brain. We have said that addiction is a relapsing disease, right? It's because of its chronic nature that it's relapsing. So relapsing is not only possible, but it's common. When we see our clients, the possibility of a relapse, we should understand that is there. And why do we say it's possible? Because we know it's chronic. So we know it's something that is as, it happens the same way as diabetes. Diabetes is chronic, it's managed. So we should actually always be anticipating relapsing, not that we should work towards saying that our clients should relapse, but it's a possibility. I've worked with clinicians where they become very disappointed because our clients have relapsed. But one thing in part of recovery, we know relapse is part of it. It's more common. Now, you can think about the relapse of addiction as a chronic disease and think about any other chronic illness. For this slide, there's a comparison of the relapse rates between drug addiction and other chronic illnesses, right? So the green shows drug addiction. Type 1 diabetes is highlighted in the blue, and then hypertension is red, and then asthma. When we look at the slide for drug addiction, actually the relapse, it's 40 to 60%, right? And then diabetes type 1 is 30 to 50%, which is slightly lower than drug addiction. But hypertension on the other end is 50 to 70%. So you see that some of the chronic illnesses, actually, the relapse rate, they're actually higher than drug addiction. And then the same is true when you look at asthma. The relapse of asthma is the same as the relapse of hypertension, and both of these two chronic illnesses, they have a higher rate of relapse as compared to drug addiction, right? So we can see that, like, in terms of coming back to our definition of what addiction is, it's a chronic, relapsing, Fatima, you are nodding, brain disease, right? That is characterized by compulsive seeking use despite harmful consequences. So the reason why we would want us to always have an understanding that addiction is a brain disease is because of all these factors that we've just gone through over the slide. It's not just the disease, it's a relapsing disease, it's chronic in its nature, and it affects how the brain functions in the structure of the brain. Now, in terms of relapse and lapse, these are two common terms that we are familiar with, but there's a clear distinction between the two terms. And lapse, right? It's very brief. It's often one time return to the substance use. An example would be probably for a client who goes by a friend's house, they find the friend using, they find themselves using too. But then after that, they regret and do not continue use. That's a lapse. It's very brief, right? And then relapse on the other end is a complete return to using substances the same way the person did before he or she quit. So there has to be some sort of period where somebody was not using the substance, and then they go to the same pattern of use for us to say that they have relapsed. And lapse can lead to a relapse, but it doesn't always have to be that way. Like as I've already said, a lapse is often brief. It's one time and then you go back into your recovery. But at times a lapse can lead to relapse, but not all the time. So relapses can be avoided through recovery interventions that will probably be covered in another curricula that we are going to be doing after curricula 1. So that is the distinction between lapse and relapse that we would want all of us to understand. And therefore, we'll move on to the brain itself and see how we are saying that addiction is a brain disease, how psychoactive substances affect the brain. And I'm going to give my colleague, Dr. Beatrice, to continue from here. I see a hand. Is it a hand of asking? Galaxy TV, yes.
Maybe you can stop share, then I can.
Okay. Yes, thank you.
Thank you.
Yes.
So thank you very much, Morekwe, and good evening, everyone. Just before we begin, I want us to do a little exercise to make sure that we are not asleep, because it is, for some of us, it's late in the night. So I'm going to give you instructions. In just 2 minutes, you're going to do a couple of exercises. So the first one is I want you to raise your hand. Can you raise your hand? Yes, I'm not seeing you raising your hand. Okay, very good. Next, I want you to touch the back of your hand very lightly, the back of your hand. Very lightly, a very light, gentle touch. Yes, a very light one. Yeah, as if you're rubbing very gently. Okay, good. Thirdly, I want you to look around your room and I want you to name one color that you see. Look around your room and identify one color that you see. Okay, good enough. Thank you. Next, I want you to stand up and balance on one leg and make sure you don't fall. Yes, and balance on one leg and make sure you don't fall. Okay, good. You can sit. Thank you. Next, I want you to pinch the back of your hand. Pinch the back of your hand a little. Yes, just give it a small pinch. Yes, very good. Next, I want you to remember your first teacher in kindergarten. The name of your first teacher in kindergarten. Please remember. Thank you. Now, because you have remembered, I want you to clap for yourself. Clap for yourself. Very good. And finally, now I want you to listen carefully. Because we come from Africa, I know we all know what a goat is. We know what a leopard is, or a tiger. And we also know what grass is. So you have 3 things. You have a goat, you have a leopard, and you have grass. And you want to cross a river. And only cross the river with 2 items at a time. So how are you going to cross the river and ensure that all those items are on the other side of the river? Okay, so now I am sure that you're trying to find an answer, and that can be part of our discussion, but I want to introduce this slide here that is introduction to the brain. So when I asked you to stand up, your brain was helping you with movement, or when I asked you to raise your hand, When I asked you to feel the back of your hand, you were actually feeling a sensation and your brain was helping you. When I asked you to find a color in your room, this was actually part of your brain that was helping you with vision. When I asked you to try and stand up, like a part of your brain right here was helping you with coordination. And when I asked you to pinch yourself a little, there is a little part of the brain here that was also made you feel the little pain. I'm sure you may felt a little pain. And when I asked you to remember your kindergarten teacher, another part of your brain helped you with memory. And when I asked you to clap for yourself and you felt good, another part of your brain called reward circuit was helping you. And finally, when I gave you the task of crossing the river with those 3 items, and you're gonna be giving me the answer on the chart, you are using this part of your brain trying to make some decisions, some judgments, some problem solving. So what this slide illustrates is how complex our brains can be and how many different things they enable us to do. And understanding the brain is important because if you have remembered what Morekwe just said, she said that addiction is a brain disease. So it's important that we begin to understand the organ that is affected when our clients use substances. So that's why this slide has been presented. The next look at is brain communication. And we wish to understand that the brain is a communication center. You know, every time I think about the brain and a communication center, sometimes I think about the different organizations in our countries that manage communication, and they are big time. And you know, that just helps me understand how big time our brain is. And it has got billions of neurons. In fact, some literature says it has over 86 billion neurons in our brain. So that is just the magnitude of what it is. And a neuron is a specialized nerve cell which has got specific features. And why does it have specific features different from other cells? Because it is basically designed to be you know, a tool for communication. So it's designed in a way that is going to make communication its core business. So it has got the cell, which is typically in every, you know, every cell has got a body, and we can see that. But at the same time, it has got something else. It has got something here we call dendrites. They are hair-like, you know, extensions here. You can see it has the body and it has the nucleus. Then it has got what looks here like a stick called the axon. So the axon is very important in terms of transmitting messages. And because of how important it is, it's covered by a sheath, which is called the myelin sheath, basically push it so that the impulse is transferred much more quickly. Sometimes I think about the power cables in our houses and how they've been cushioned to ensure that we are not losing out on any bit of transmission. I think that's the way I understand this sheath. Then we've got the tip of this stick, which is called the axon tip, which has got receptors here, which are very important because we need to send messages and receive messages. So that is the nature of the cell that we call a neuron. So it's a specialized cell whose business is basically communication. Now, the next thing we need to understand is that these neurons pass messages back and forth to the different structures within the brain. And also the I think the was introduced the central nervous system. He said comprises of the brain and the spinal, but he also mentioned that you also have the peripheral nervous system that moves from the central nervous system to the exteriors of the body, the legs and the hands, the arms and the feet. So we are saying that neurons pass messages across these networks. Now, we need to understand what is a normal brain communication so that we can understand how drugs interfere with normal brain communication. So in the next slide, we're going to demonstrate how normal brain communication happens using one example of something we call dopamine, which is an example of a chemical messenger that is used in the process of communication in the brain. So communication in the brain uses neurotransmitters, or what we call chemical messengers, to put it, sometimes in simpler language. And a good example is dopamine. Now, here in this slide, we have two examples of neurons. So the upper one here, I hope you can see the cursor, is the sender neuron. And the next one here is what we call the receiving neuron. And in between the two, we have got a space here that is called the synapse, or sometimes the synaptic cleft. So this space is where a lot of activity occurs between the first neuron, which is sending messages, and the second neuron that is receiving messages. And these messages are sent through the neurotransmitters, and a good example is dopamine. So in normal brain communication, this neuron here, which is called the sender neuron, will release this neurotransmitter called dopamine, and dopamine will come through the synaptic cleft into the receiving neuron. Now, this receiving neuron has got sites to receive the neurotransmitter, and these are called receptor sites. Therefore, every receiving neuron has receptor sites for specific neurotransmitters. For example, these are receptor sites for dopamine neurotransmitter. If another neurotransmitter comes here, it will not be able to send its message to this neuron. So we need to understand that there are many different neurotransmitters, and there are many different receptor sites for the different neurotransmitters. And for a message to be sent by a neurotransmitter, it must interact with the correct receptor site. So this is a receptor site for dopamine. And this is illustrated by this slide, which says that a neurotransmitter and its receptor site operate like a key and a lock. You cannot open a lock with a different key that does not belong to that a padlock or lock. And therefore, that's the same way it is for brain communication. For messages to be transmitted, the neurotransmitters must get into the receptor sites of those specific neurotransmitters. That is the key message. Now, here is an example of communication using dopamine. So dopamine is released from this sender neuron. It comes into the receiving neuron, gets into the receptor site, activates the communication, and immediately after that, it goes back to the sender. Now, for it to get back into the sender, it goes through something called dopamine transporters. So for the dopamine to be taken back for recycling into the sending neuron, it requires dopamine transporters. This is important for us to understand because it is not every neurotransmitter that works with transporters, but dopamine is one of them. And therefore, after dopamine activates the receiving neuron and passes the message, it goes back and it is recycled back into the sender through the dopamine transporters. That is a normal communication. And we have an exercise in the next slide that you're supposed to practice when unfortunately, when the corona is not a good activity because it involves touch. And this is one of the things we have to be able to avoid during COVID-19. But COVID-19 is over, we'll be able to practice these activities. It's an exciting activity because you want people to practice to try and understand how the brain communicates. So in this activity, you have got some people acting as neurotransmitters. We have others acting as the sender neuron, others are acting as the receiving neuron, and others are acting as transporters. And the idea is to help them role play how the neurotransmitter is being discharged by the sender neuron, who is another, it's being taken to the receiving neuron, is another person, and then it attempts to go back through the transporter, get back to the sender neuron. So that is demonstrates the normal brain communication. When Corona is over or COVID-19 is over, I hope we cannot practice this activity back in our countries. For now, we will not do that. Now, this slide illustrates the volume of neurons we have in our brain, and I think you can see what we said there. So what we need next to understand how psychoactive substances can affect this normal brain communication. And they can affect in many ways. And one of the ways is to mimic the neurotransmitters. For example, they may act as if they were the natural brain neurotransmitters. Other times, they may actually disrupt the way the messages are sent. And we are going to see in the next slides how that happens. So this is an example of cocaine. Cocaine, as you know, is one of the drugs that we call stimulant drugs. If you look, we have got, again, the sender neuron, and we have got the receiving neuron here. So the sender neuron is actually discharging our dopamine here, which is looking orange. I'm not sure what color you're seeing, but I will call it orange myself. Sometimes I hear some of us are colorblind, especially some gender. So this is what I'm calling orange. This is dopamine. It's being discharged from this sender neuron. It's coming all the way to the receptor sites here to be received. And now it's trying to go back to the sender neuron for what we call reuptake via the transporters. Unfortunately, it finds that the transporters have been hijacked by cocaine. This is cocaine, the green is cocaine. So cocaine has attached itself to the transporters. So when dopamine is trying to go back, it cannot go back, and therefore it cannot be taken into the sender neuron. And so it remains here and continues to activate and send messages to the receiving neuron. And that causes some sort of mobbing, and that is what causes what we have as the cocaine high. And we're going to be watching a video to demonstrate that shortly. So there's an activity here to illustrate how cocaine, again, affects the brain. Again, when COVID is over, you're going to practice this with your participants. Now you would have transporters. In this case, you're going to have the neurotransmitter, dopamine. You're going to have the cocaine this time. You're going to have the sending neuron and the receiving neuron. And you're going to demonstrate, or the activity is going to demonstrate how the sender neuron sends dopamine. It goes to the receiving neuron. Then on its way back, it finds that the transporter has been hijacked or blocked by cocaine. So it cannot go back to the sender. So it goes to start continues activating the receiving neuron until the receiving neuron is almost overwhelmed by the activation. And that causes the cocaine euphoria. So now, next, I'm going to request Kerry to play for us a video just to illustrate that a little more. Kerry.
Do you have to stop your screen sharing, or can I just go?
I think so. I think so.
Okay. Here we go.
Okay, so there we go. So we have got this little video. Just before the video begins, Kerry, let me explain that on this side, we have got the normal communication without cocaine. And on this one to your right, we have got the effect of cocaine. So you're going to be watching these two neurons, the one on the left that is showing the normal communication, and the one on the right that is showing communication that has been affected by cocaine. I'm going to be talking into them as the video shows. Please, Kerry. So you can see the dopamine coming down from the sender neuron into the receiving neuron and sending the message, and then going back. You can see on this side, it goes back and the transporter takes it back. But you notice on the one on the right, orange is cocaine. When it tries to go back, it finds cocaine has bound itself to the transporter, and therefore it cannot be taken back or recycled. So it's left here, and you can see it continues to activate the receiving neuron. And that's what we are saying causes the euphoria that's associated with cocaine. Thank you, Kerry. So sorry about that. I think I went back a little. So we have demonstrated that we've demonstrated how cocaine affects the brain, and also here that is heroin works in a slightly heroin works not by hijacking the transporters, actually works by binding itself of natural opioids. As we know, natural opioids include, there are several, And some of them, I think they are called endorphins, and they are supposed to give, to manage pain naturally. And they support us in managing pain. But when heroin is taken by the client or by the persons that use heroin, they tend to bind themselves to the receptor sites of the natural opioids, and they cause a higher, much higher effect compared to the natural opioids. And so in this exercise here, heroin is supposed to, you know, your participants or your students are supposed to demonstrate how heroin affects the brain. And so some people will act as heroin, others will act as the sending neuron, others will act as the receiving neuron, and now and others as the neurotransmitter. So the neurotransmitter will try to bind itself to the receptor, but it will find that the receptor site has already been taken over by heroin. So heroin works by mimicking the natural neurotransmitters. So in short, what those slides are trying to demonstrate to us is that psychoactive drugs interfere with the normal brain communication. Sometimes they will do it by blocking certain neurotransmitters. Sometimes they will do it by mimicking certain neurotransmitters. Sometimes they will hijack the activity of certain neurotransmitters. Now, next we are going to look at the parts of the brain that are most affected by substance use. And 3 of them have been selected. And the key thing is, these are not the only ones. There are many others that are affected, but these are the ones that are largely affected. That's why they've been selected. So we have the brain stem, we have the cerebral cortex, and we have the limbic system. And so the brain stem is a part of the brain that is below the neck or around the back of the neck, which is very critical because it supports critical functions. By, for example, breathing, your heartbeat, control. When drugs affect because of their impact on this part of the brain. The cerebral cortex is actually I call it your master in terms of decision making, your master in terms of judgment, your master in terms of problem solving, like the problem you are trying to solve. These are the areas, you know, of the brain that deal with that. And you can see again, when they become affected by drugs, no wonder sometimes we said that our clients have a problem with processing of information. Sometimes they have a problem with their judgment, you know, like when they consume a substance like alcohol, you can see problems with judgment, is because the cerebral cortex becomes affected. And important is the limbic system. The limbic system, if you ever forget everything, just remember it's the this is what this is where the reward. When I asked you to clap for yourself and you felt good, activity was happening around here. And this is a critical area, and we're going to talk a little more about it. So addiction and the reward circuit is important to understand, because just like Rebecca said, people are not addicted because they have a character flaw, or because they're or because they do not have sufficient willpower. Disease has to do with this reward circuit of the brain. And we are saying that naturally, our brains are wired to ensure that certain activities that we do and they are become remembered and they are repeated. And because of that, they are associated with pleasure and reward. Of course, some of the examples of these activities is eating, like drinking, the behavior. All these are supposed to be life-sustaining activities. And so we are saying that we have learned to remember to repeat them because they are pleasurable and this is because of that part of our brain that we call the limbic system, that connects our, you know, our memory, that connects our feelings of pleasure. That is what we are calling the reward circuit. Now, what addiction does is that it overstimulates this reward circuit. And because of overstimulating, and we have just given an example, for example, of how when cocaine interferes with communication, the kind of reward from cocaine is completely different from what would be from anything else. We also said even heroin, when it interferes with the brain communication, the kind of effect is much higher than would be felt by natural opioids. And therefore, we are saying that substances of abuse produce euphoric effects that are much higher than those of the natural behaviors. And because of that, they will cause people who use psychoactive substances to want to repeat them repeatedly. And that is what addiction is about. That's why we are saying it is a disease. Now, this slide illustrates how significant the reward from psychoactive substances is compared to that from naturally rewarding behaviors. And it has been argued that sometimes it can be up to 2 to 10 times more. And that's why this container is very big and this one is much smaller. So when someone begins to get the reward of psychoactive substances, it cannot be comparable in any way to what we find naturally rewarding. And that's why the drugs take over their life. And now the other important thing to understand is, as the person continues using the drug and they are getting all these surges or dopamine, the brain has to find a way of coping. And the brain in different ways. One, it might decide to start producing less dopamine. That is one way of adjusting or adapting itself. So by producing less dopamine, then it protects itself from being overwhelmed. It can also adapt itself by reducing the number of receptors as a way of trying to cope with the overwhelming dopamine that is being caused by the substances of abuse. Unfortunately, when that happens, there is an impact, because then the person now can no longer experience reward from the normal life activities, because the brain has adapted, the brain has adjusted itself to try and cope with the problem, but in the process created a new problem for the user. So the user now gets depressed when they are not using the substance, because what was normally a naturally rewarding before the use of substances is no longer rewarding. It even gets worse, so that even the substance they were using, the amount they were using does not give the same reward. That's what we're going to be talking about. An example here is dopamine. You can see how the effect of drugs, that is chronic cocaine use, changes the levels of dopamine receptors. So here on the left, we have a healthy brain. The red marks here are showing the levels of dopamine receptors. So you can see there are many. As the person uses cocaine repeatedly on the right side, we have said the brain adapts to cope with the surge in dopamine. And one of the ways is to actually reduce the receptors for dopamine. So you can see that on the right, the person here has got a brain which has got highly reduced dopamine receptors. So it means that even when this person tries to feel happy by doing the things that ordinarily make an individual happy, they cannot achieve that because of this brain adaptation. And that now, again, supports the idea of addiction being actually, this affects the structure of an organ. So you can actually see here that something has happened to the structure of the brain, what is in the brain. And that is the reason why we end up with a condition called tolerance. Tolerance is a situation where the person has to use more of the substance they used to use previously to get the same effect they used. And when we talk about more, it could be more in terms of quantity, it could be more in terms of dosage, it could be more in terms of the idea is they're trying to beat the adaptation of the brain. So the brain has adapted, doesn't feel itself when you took that substance because it has reduced the neural and the receptor sites, or it has reduced the sort of fraction of dopamine. So now for you to feel the same effect you felt previously, you have got to take more of the substance, or you have to take a strong portion of the substance. That's why you see people graduating from swallowing to snorting to even injecting, because they are trying to beat tolerance. And we said that tolerance is one of the characteristic manifestations of addiction as a disease. So thank you very much. And my slides are there. Next week, Moses is going to take you through now the process of how a person gets from beginning to use all the way progressing to addiction because of these biological processes like tolerance. So I stop there, and because we have about 4 minutes, Carrie, maybe we can go to some questions. Thank you.
Okay. You're giving opportunity for questions?
I could check in the chat, or perhaps we could. I think I see a hand here from someone called Galaxy Tab. Is that so? Maybe you can unmute him and he can ask the question.
Sure. Let's look. Okay, and I see George raised a hand.
Raised his hand, yes.
So we can take 2 questions because we have about 3 minutes, and the rest we shall respond to on the group email. So
Okay.
Galaxy Tab. Yes, Galaxy Tab A.
Let's move on to George, and then we can go back if a question remains. Go ahead, George. I unmuted you.
Actually, my question was about the goat and the leopard. What happened?
The goat and the leopard, we are going to answer in the group chat, the goat and the leopard. I must get answers. So that's your homework. Thank you.
Good, good.
So Galaxy, any question?
No.
Okay. So I think what we do, we will ask for more reactions to be posted on the group chat, and we can interact more there. Yes, otherwise, thank you very much.
George raised his hand.
And the diaper question has been answered in the group chat. I know someone else mentioned that, so yes. All right, everyone take care, be well.
Thank you, and good night.
Good night.
Or good morning.
Thank you.
Yes.
Good night, everyone.
Night.
Thank you. Good night.
Good night.
Good night.
Good night. Thank you, Beatrice and Marique.
Thank you too.
Thank you. Thank you.
Thank you. Good night.
Night.
Thank you for the presentation. Good night.
Night. Thank you. Game is here.